Now we move on to traffic volume characteristic. We have to take note that traffic volume on a certain section of the roadway varies from hour to hour, from day to day, and from month to month. The regular observation of traffic volume over the years has identified certain characteristics showing that although traffic volume at a section varies from time to time, this variation is repetitive and rhythmic. So we have to take note that the characteristic of traffic volumes are taken into consideration when traffic counts are being planned so that volumes collected at a particular time or place can be related to volume collected at other times and places. So we have here variations showing to us the uh, traffic volume on an urban highway. So we have here traffic volume on an urban highway. So we have here monthly traffic variations. So we have here the illustration for daily traffic variation. And this one is the hour of day. This is an hourly traffic variation. So So you can observe here based on our illustration, you could identify what particular year, what particular day, or what particular hour that has the greatest number or the greatest has the volume, has the great volume traffic or has a big volume traffic. Then this one is the summary of traffic volume data for a highway section. So this was we have to take note that in our illustration for the variations of volume of traffic volumes, it has a variation actually. It varies from an hour to hour, from day to day, or from month to month. Then we move on to sample size and adjustment of periodic counts. The impracticality of collecting data continuously every day of the year at all counting stations makes it necessary to collect sample data from each class of highway and to estimate annual traffic volume from periodic counts. So actually this involves the determination of the minimum sample size, referring to the number of count station for a required level of accuracy, and the determination of daily, monthly, or seasonal expansion factors for each class of highway. So for the determination of number of count stations, so the minimum sample size depends on the precision level desired. So the commonly used precision level for volume count is 9-5. So meaning to say when the sample size is less than 30 and the selection of counting station is random, the distribution known as the student's t distribution can be used for us to determine the sample size for each class of the highly linked. You have to take note that our student's t distribution is unbounded with a mean of 0 and has a variance that depends on the scale parameter commonly referred to as degrees of freedom. And that degrees of freedom being denoted by a small letter v is a function actually of a sample size, and that is equal to n minus 1. N refers to the sample size. And for the student, this is for the student's t distribution. For the variance of the student's t distribution, that is v all over v minus 2, which is an indication that v approaches infinity, the variance approaches 1. So the probability or the confidence level for the student's t distribution for different degrees of freedom are given in our appendices. So assuming that the sampling location are randomly selected, so we have to take note that the minimum sample number is given by this equation. So small letter n refers to the minimum number of count locations, and that is equal to this expression. Our t is the value of students' t distribution with 1 minus alpha all over 2, and the level of confidence is n minus 1 degrees of freedom. And the total number of links refers to our capital N, and alpha is the significance level. Our capital S is estimate of the spatial standard deviation of the link volumes, and D is our allowable range of error. So we have here an illustration to determine the representative value for ADT on a 100 highway links that have a similar volume characteristic, it was decided to collect 24-hour volume counts on a sample of this link. Estimate of mean and standard deviation of the link volume for the type of highway in which these links are located are 32,500 and 5,500 respectively. Determine the minimum number of stations at which volume counts should be taken if a 95-5 precision level is required with a 10% allowable error. So which means that for this one, our alpha is equal to 100 minus, since we have here 100 highway links, so that will be 100 minus 95, so we give us alpha is 5%. And our S is, we have here the S value is 5,500 and our M here is 32,500. This is now our mean, which has 32. This M, small letter M, refers to mean, that is 32,500, and our capital S is the standard deviation, which has 5,500. So therefore, our D, which has our allowable range of error, is 0.1 times 32,000, and that is 32,500, which gives us 3,250, because we are given here with a precision level which is required to a 10% allowable error. So we have to multiply. So 10%, that is 0.10 times our mean. So that is our allowable range of error is 3,250. So therefore, our small letter V is equivalent to 100 minus 1, so which gives us here 99. So which means that from our appendix, if we're going to have here, if we're going to refer to our appendix A, our T, which is a function of alpha all over 2 dash 99, so that will give us 1.984. We have to take note that small letter V is actually equal to N minus 1. So that gives us here 99. So from appendix A, you can now get the value of T's of alpha all over 2 dash 99. So that gives us 1.984. Now, if we're going now to substitute the values to our formula for our small letter n, we can have the value now for our minimum sample size. So the minimum sample size is equal to this equation. So if you try to substitute the given value for each variable, you get a value of 10.1, or can be equivalent to 11 stations. So when the sample size is greater than 30, the normal distribution is used instead of the student's T distribution. Now, for adjustment of periodic counts. So expansion factors are used to adjust periodic counts. It's either determined from continuous count station or from control count station. So expansion from continuous count station, it can either be hourly, daily, or monthly expansion factors, can be determined using data obtained at continuous count station. So the hourly expansion factors, HEF, are determined using this equation. So total volume for 24-hour period over volume of particular hour. So these factors are used to expand counts of duration shorter than 24-hour to 24-hour volumes by multiplying the hourly volume for each hour during the count period by HEF for that hour and finding the mean of that product. Then for our daily expansion factor, for the daily expansion factor, you have here the equation, which has average total volume for a week over the average volume for a particular day. So this factor are used to determine weekly volume count for 24-hour duration by multiplying the 24-hour volume by the DEF. Then for our monthly expansion factor, MEF, it is computed using this equation. AADT all over ADT for a particular month. AADT for a given year may be obtained from the ADT for a given month by multiplying this volume by the by the MEF. So we have here our hourly expansion factors for a rural primary road. So we have here the tabulation, and this one is the daily expansion factor for a rural primary road, and this one is the monthly expansion factor for a rural primary road. So we have here illustration. A traffic or engineer urgently needs to determine the ADT for on a rural primary road that has a volume distribution characteristic as shown in table 4.5, 4.6, and 4.7. She collected the data shown below on a Tuesday during a month of May. Determine the AADT of the road. So this is collected on May, and it was Tuesday of the month of May. So we have here the daily collection on Tuesday for the month of May. So if we're going to estimate now if we're going to estimate the 24-hour volume for Tuesday using the factors given in table 4.5, we simply have to multiply. So from table 4.5, 7 a.m. to 8 a.m. Table 4.5. So this is our hourly expansion factor from 7 a.m. to 8 a.m. So that is 29. Then so it started with 29. Then for 8 a.m. to 9, so we have 7 to 12. So we have here. So which means that from 7 a.m. to 12. So we're going to make use of this hourly expansion factors. 29, 22, 18.8, 17.10, and 18.52. So you multiply the value for each of our value for this specific time, 400 times 29.0. This is the hourly expansion factor. For 7 to 8, for 8 to 9 is 22.05. From 9 to 10, 18. Then 10 to 11 is 17, and 11 to 12 is 18. So you simply have to multiply those specific value correspondingly. So this 1, 2, 3, 4, 5 divide to 5. So you have now your estimate 24-hour volume for Tuesday, 11,959. Then adjust the 24-hour volume for Tuesday to an average volume for the week using the factors given in table 4.6. So we're going to have here for the total 7-day volume from table 4.6. So we have here for table 4.6, we have here for Tuesday, so that is the daily expansion factor for Tuesday is 7.727. So we simply have to multiply our 11,959. So it divided by 7. So which means that they have now a value of 13,201. Then, since the data was collected on May, so we're going to make use the 4.7 table. So what is the multiplier here? It was collected on May, so this is our equivalent value. So that is multiplied to our monthly expansion factor, 1.394. Multiply that to 13,201. So which means that our ADT is equal to 18,402.